pretend no one has any earbuds in because they are paying 100% attention. So, we're going to talk about a couple of these things. This is not really going to be too much of like actual problems, but this is helping to understand certain things. So you're not going to have too many problems on this that it's going to be like, oh hey, you need to know this. But understanding in the overall is going to help. So if you notice the sides right here, A, does that look like the smallest angle there? Yes. So across from it would be opposite that, would also be referred to as little a, is going to be the smallest side. Angles correspond with the sides. Angles correspond with the sides. So the smallest angle goes with the smallest side. Let's go over here. Does A in this one here look like the biggest angle? Yeah. Yeah, it looks like the biggest angle, isn't it? It would be because that one's the what? Start with hypotenuse. Now, hypotenuse is how much? So right here, it's across here. So this is 90. It's across from the right angle. So that, is it possible to have two angles in a triangle that are 90 degrees? Yeah, there we go. So we cannot have more than that. So by looking at this, I know that A is going to be bigger than this one up here, right? So that means that Y has to be greater than X, isn't it? So over here, I know that my Y is going to be less than X, right? Does that make sense? And this is Y is greater than X. So this is just important because when we get into the different types of triangles later on, this is something you need to actually understand. Largest side, largest angle. Now, with your handy dandy calculator, which everyone should have right now, and not a phone in their hand, because hell no, to the no, no, no. Do they have a cell phone in their hand? Because no one would do that, right? So sine 21 greater than sine 18. So let's check it. So it's called a test. So in the calculator, we're going to do a test. So sine, and what was my angle? 21? So 21, and what can I not forget? Degrees, okay, is going to be, it says greater than, so the test is right here. See where control is? Right below control, there's the equal sign. So hit the equal sign. So control, equal sign, there it is. Greater than, so this is where your testing ones come in. Is that one not turning on? Yeah, there's a reset in the back. You need a pen to do it. We need new batteries on these calculators, so. Huh? Because these are the lithium batteries and they're like $12 a piece. But if you actually go and try and buy actual batteries, you know, for a 4-pack of batteries, probably $12 anyway. So it's still cheaper for rechargeable. All right, greater than, so the next one's going to be sine 18 degrees. What else do I have to make sure of here? Look at my calculator. The mode. My mode has to be in degrees. So let's click on that. There we go. And I'm going to hit enter. Unreal calculation. Yeah, bring it over so we can show you what's wrong. Yeah, so the inverse. Super easy, right? All right, so your calculator is your friend. So when I tell you over and over again, work while you're in here because you have access to these calculators. That's important. Now the next one, let's look at the next one. It says secant 56 is less than equal to secant 49. Yep, so these calculators, unlike the other calculator, the Wabbit one, this one actually has a secant, so you don't actually have to do anything crazy on it. I'll show you. So secant of 56 is going to be greater than, or is it less than equal to? Less than secant 49 all set. Super easy, right? Now, so I'm going to show you how to do it on the other calculator here in a second. So the first thing we have to understand, because the other calculator only has sine, cosine, tangent. Now, secant. What is secant actually? What is it? It's a reciprocal of what? Which one? Not sine. Cosine. So secant is r over x. So that's the reciprocal. So it's r over x. So that's going to be the reciprocal of cosine. Now, we're going to write it in terms of cosine. So if this is the reciprocal of cosine, what does that mean? What does reciprocal mean? Just flip it over, right? So flip it over. So that's what I'm going to do here. I'm going to flip over this. So when I flip this over, it's going to become, because it looks like this right now, right? We can write any number as a fraction by putting it over 1. Yeah? So we're going to take the reciprocal now. So the reciprocal of this is going to be 1 over cosine of like that. So it's the same thing. It's just you have to understand your sine, cosine, and tangent. You have to understand those. So I'm going to go to the other calculator here. And I'm going to change my mode. So you guys that are following along on the video, mode, down, over, change to degree, enter. Second mode again is going to quit out of that menu. And then I'm going to go to my fraction, because I like writing this out with an actual fraction. So everything that this actually does in the calculator, everything that you're going to find is actually going to be under math. So I'm going to hit math, and I want to go to fraction, which is right there. So that's where I have my fraction, and I want n over d. What do you think n over d stands for? Numerator and denominator. There we go. Numerator and denominator. That's all I want. Okay? So that's going to be option 1. And we said that's going to be 1 over cosine 56 degrees. and degrees is right here. Now, see this? On mine it's purple. On yours, I don't know. But it's under angle. If you see that word in blue, it says angle.
Oh yeah.
Yeah, so angle, that's where it's going to be my degrees and all that other stuff to go along with that. So I'm going to hit second, apps, will bring, there's my angle, so there's my degrees, there's my minutes, that's a symbol for radian, and there's my DMS if I am looking for DMS. So you can still do the same stuff, it's just in a different location. And that's going to be my degrees, and close, and then, now, what am I going to do here? Okay, so I said math. Now I gotta try to remember where it's at second. It is, oh, it's test. Sorry. So test is right here, it's in blue. So I'm testing it to be less than equal to. I thought the test was in a different one. So option 6, and now do it again, set up my fraction. And I'm trying to encourage people to actually do the work here in class and not sit there and, you know, whatever you do as you stare off into the, yeah. There we go. Okay, the test comes up 0, it's in binary, false, and a 1 would be true. Okay, so a 0 is false, 1 is true. So that's how you're going to see this. Does that make sense? Okay, good. So, yes, it is possible because there are some people missing today and they're going to have to watch this video and then learn how to do it on their calculator, because they're not here today. But other than that, so my answer for this first one was true, and this one's false. Okay, 30, 60, 90 triangles. Bisect one angle of an equilateral triangle. What does equilateral mean? Yep, all sides and all angles. Very good. All sides and all angles are the same. So, if you notice, this one, equilateral, every side is 2. So, this is broken up into 2 separate ones. So, this is 1 and 2. I'm going to tell you right now, it's always going to look like this. So, this is going to turn into something square root of 3. This is the formula. So it's going to look like this. So if you write it out, and I normally don't give this as a formula, this is n, this is 2 times n, and this is n times square root of 3. So every single time that I do one of these, this is my 90, this is my 60, this is the 30, this is how I do this. So if I know what this side is right here, if I know what the bottom is, what would I do to find the hypotenuse? Multiply by 2. What would I do to find the height if I had this one right here? Multiply times square root of 3. But it's a radical, so guess what? You could just leave it alone. You don't have to put it in the calculator. Okay, radicals are your friend, leave it alone. It's kind of like pi. All those people that want to try and approximate pi, don't. Just write the pi symbol. That makes your life so much easier. Yeah, Denny knows it to 1,000 places. So, there it is right there. And there's another one. This one is a 45, 45, 90 triangle. Okay, 45, 45, 90. So now, I know that these two sides in a 45, 45, 90 because the angles correspond with the sides, right? If the angles are the same, what about those two sides? Yeah, 2 of the sides are going to be the same because across right here, that one and that one there, going to be congruent to each other. So if I were to try and make a formula out of this, I would call this one, let's say, x, and this is going to be x times the square root of 2. If I was trying to make a formula out of this. So these two are the same, so it's x, right? And the hypotenuse is going to be always whatever this value is times the square root of 2. I know I'm going over this kind of quick and it doesn't really make sense until we put some numbers in there. Did we write this down? Okay. Yeah, so write it down. Did you write down the other one too? Shame on you. We're going to come back. So I wanted to give you guys the formula so you could actually see. Like all this stuff right here really doesn't make sense until you're actually applying it. You're putting numbers to it, and then you could actually, oh, that's where that number comes from. I'm not really a theory person. I'm really not. I'm not the theory person for all this. So now for this one right here, sine of 45. So it doesn't matter which one is it coming from. I'm going to call this a reference angle here. Sine. We know sine is always, and it's always some old hippie, right? Opposite over hypotenuse. So my reference angle is right here in red. So the opposite is going to be rad 2. Rationalize. Yep, so it's just going to be rad 2 over 2. When we get into the unit circle, we're going to do a lot more of this. So this is always like this. So sine 45 is always that value. It's always going to be that value. And then cosine is going to be adjacent over hypotenuse. So cosine is caught another hippie, which is rad 2. Yes, it is. Rad 2 over 2. Yeah, this last one on acid. Because someone is tripping on acid, right? Opposite is over, which is, thank you. How can it get crazier than that?
I don't know. I was thinking you get really crazy thing like that because you thought you were going to get
Okay, going back, I'm going to put it, yep. Alright, so this is what I'm going to do for you guys. So let's try this. So this is 1n, this is 2n, and this is n times square root of 3, right? Okay, because for those people who didn't write this down. I'm going to have you find a couple of these because this is what you're doing in homework. I would like for you right now on your notes, I want you to solve for little c and little a. Just given that formula that I've given you there. The ones that you don't know, which are little c and little a. Right? Yeah. Okay. All right. Come on, let me give people a chance, man. on now. Alright, so for those people that are not watching cat videos that are actually going over this, we said n value is 12.
Yes.
N value is 12, right?
Yes.
So to find the c, which is going to be the 2n side, so it's going to be 2 times whatever my n is, so this is going to be 2 times 12. Very good. And this, the height, the long leg, is going to become 12 rad. There we go. 12 rad 3. Is that too hard? Yes? No? Okay, don't overcomplicate it. Yeah, you got this. All right. Now, let's go back to this one. Now let's talk about reciprocals. So, reciprocal would be for each one. So, do we know what sine is? What's sine? Very good. Opposite over hypotenuse, right? Sine is opposite over hypotenuse. And cosecant is the reciprocal of that. So I would flip that over, right? So cosecant is supposed to be the hypotenuse over? It's going to be the hypotenuse over the opposite. What's the hypotenuse in this triangle here? Hypotenuse is across from the right angle, right? Okay, because opposite is down here. Okay, I'll call this one opposite. This one is my adjacent. And this one is my hypotenuse. There you go. So I get rad 2 over 1. Nope. Alright, secant is reciprocal of cot another hippie, right? So the reciprocal, so I flip that one over, so that's going to be hypotenuse over adjacent. So what's the hypotenuse? Rad 2, and the adjacent here is, there we go. Cotangent, this one's going to get crazy here. Okay, it's a reciprocal of tangent, which is tripping on acid. So what's the reciprocal of that? Very good, adjacent over opposite. So the adjacent is, and opposite is? So my answer is? Big brain right there. Alright, so this table is going to be helpful later on. Okay? Have it in your notes. It's going to ask you a bunch of these. Okay? Just have these available. And guess what? Don't forget to like, share, and subscribe. Hit that notification button. And, okay, support my channel by purchasing something from my merch store. I got some new items up in the merch store, so